Okay, problem number 7. Here we go. So, Grandpa buys a house in 1955. Well, of course, this reminded me of the movie Up. I don't know when Grandpa or whoever this was in this movie bought their house, but it totally reminded me of it. House values are going up. It was appropriate that Grandpa and the house need to be in this problem. So here we go. The first part is they say we're going to look for 3 different types of equations here: a linear, a exponential, and a quadratic. And so the first part, they give us 2 data points. This is all you need for a linear. And they're going to ask us to come up with the equation for that linear function. So the 2 data points would be time equals, or years is 0 and 55,000. Years would be 10 and 75,000. So 20,000 divided by 10 is 2,000. So our slope here is 2,000. So the equation then becomes 2,000x plus our initial value of 55,000. The first part says find the value in 1995. So if we take 1995 and subtract 52, we get 43. So our x value is going to be 43. From here, we're going to then plug 43 in to the equation. So we get 2,000 times 43 plus 55,000. If I distribute the 40, because I don't multiply things with the calculator very often, so I do them in a head. 4 times 2,000 is 80, or 40 times 2,000 is 80,000. 3 times 2,000 is 6,000. So then if I add all that up, I get 143,000. So that's the price in 1995. All right, the second part of A says, when will the value be 2,000? So I'm going to set $200,000 equal to my equation. Go ahead and begin solving for x by subtracting off the 55,000. And then I'm going to divide by 2,000 to get 72.5 is my x. If I add that to 1952, I get 2,024. So hang in there, Grandpa. You only have another 13 years to have your house go up over 200,000. All right, part B is asking for the quadratic, and this is one of those difficult ones where you have 3 variables, 3 equations, 3 unknowns, and we got to go about systematically solving it. Lucky for us, the first part gives us the C value, and then I'm going to use the 10 and the 75,000 to go about solving for the B. So here we go. We're going to plug in 10 in for the x and into my ax squared plus bx plus c equals y function. Subtract off the 55,000, gives me 20,000, leaves me with 100a plus 10b equals 20,000. Subtract the 100a and then divide by 10, leaves me with an equation of b equaling 2,000 minus 10a. Okay, I'm going to move over and then set up a third equation with the 15 and the 120,000. As you can see, this value is going up pretty quick in the quadratic because of that third value they gave us. So this thing's going to increase pretty fast. So here I got 15 squared times a plus 15b plus 55,000 equals 120,000. Substitute in the value for the b, go about doing the algebra, distribute, combine like terms, subtract off the 30,000, divide by the 75, which is the combined like term for the a's, and I end up with an a of 466.6 repeating. Now, I'm going to take this a and insert it in for that a and go ahead and see if I can get a b value. Alright, well if I do that, then I get b is negative 266.6. And now I'm ready to have a general equation that I can use to solve. So there's my general equation. And now they're going to ask some questions. What about 1995? And so again, I'll plug in 43 in for my x. So I'm going to square that. Blah, blah, blah. Go ahead and do the algebra. I end up with $803,000. That's a lot. Good job in the quadratic. All right. Then we're going to set it equal to 200,000 and go about solving this. So you're going to need a quadratic equation, quadratic formula here. Opposite of b. So opposite of b plus or minus the square root of b squared minus 4ac turns into 277 million essentially, divided by 2a. And I'm only going to use the plus version of this. And so I get 2666.6 plus 16,666 over about 900. And if I divide all that out, I get roughly 20 years. So the quadratic is gaining rapidly. It was going to take Grandpa 72 years in the linear. Here it would only take 20. So hopefully you have this problem done, and this is just kind of checking your work. So here we go. Now we're going to move on to part C. We're going to get a general equation. We've got two data points, which is all we need. So we've got 55,000 for a 0x, so that's my AO value. So I'm going to put 55,000b to the 10, and if I have 10 years on there, then the value is of course going to be 75,000. So now I have b to the 10 equals 75,000 over 55,000, which reduces to 75 over 55. To get the b down to 0, I'd take the 10th root. So all this is going to equal my base value, or my b value, up above. Plug it back into the general equation, and now I can solve for the 1995 value, which again is my x of 43. So 55,000 times my base raised to the 43rd power gives me 208,721. So in 1995, I got 208,000 according to this quadratic model. Now the question becomes, when will it reach 200,000, which obviously it's going to be slightly less than 1995. Hopefully we're going to get enough of this. So here we go. 200,000 formula here. Divide by 55,000 on both sides. I get 3.63 repeating, and equals b to the x. The b value was 1.0315, so take the natural log of both sides, divide that out, and I get x equals 41.6, which hits my mark, hits my target, which I thought it should, of having an x value equal to something less than 43. So here we go, a little practice problem. When will the exponential function equal $500,000? So $500,000 equals